Good evening, everyone, and welcome to this TAG Talk. Thank you very much for joining us this evening. I'm Georgia Christa, TAG's event coordinator, and we are delighted to have this evening with us a faraway guest, Maher Abu-Samra, to present his talk, A Stone Oasis, Traditional Architecture and Construction Techniques in Jordan. Architect Maher Azmi Abu-Samra, founder of Mass Design Studio, was initially educated in modernist principles, receiving a bachelor's degree in architectural engineering from the University of Mosul, Iraq in 1998. He's a senior researcher and assistant at the Qatar Faculty of Islamic Studies, part of the Qatar Foundation. Previously, he served as a senior researcher and assistant to Professor Abdel Waled El Wakil, where he actively contributed to research initiatives. In 2016, he founded Mass Design Studio in Amman, Jordan, where he currently serves as principal architect. The studio is a consulting architectural firm specializing in traditional architecture, focusing on stone construction with load-bearing walls and vaulted ceilings. Throughout his diverse range of projects, Maher has had a unique opportunity to apply the design philosophies of traditional Arab houses, continuing the legacy of the Egyptian architect Hassan Fathy. In 2015, Maher authored a book based on the manuscript Geometric Construction Necessary for the Craftsman, originally written by the prominent Muslim mathematician Abu al-Wafa al-Buzjani around 917 CE. The book is in a depth study of one of the most significant works of Islamic geometry. Maher meticulously collected, compared, and analyzed various copies of the original manuscript, reproducing a refined version of the drawings using computer-aided design software. He aligned those visuals with al-Buzjani's detailed explanations, demonstrating over 130 complex engineering applications. Maher also provided simplified interpretation of this equation, aiming to make them more accessible to craftsmen and artisans working in art, crafts, and the broader context of Islamic scientific heritage. In this talk, Maher will explore the captivating geometry and philosophy behind those stone structures, demonstrating how traditional architecture can serve as a sustainable, resource-efficient alternative. This echoes Fathy timeless advice: look under your feet and then build. As usual, the talk will be followed by a session of questions and answers. If you have questions during the talk, please type your questions in the message bar at the bottom of the screen. And after the talk, I will invite you to unmute your microphone and ask directly your questions. I will let Maher now to present his work, and thank you again for offering us this very exciting talk. If you can share your screen, Maher, and thank you very much.
Thank you, Georgia.
That's fantastic. Thank you.
And really thanks for giving this opportunities to explain what we are trying to do here in the Middle East. And we are away from Europe, but this construction technique based on traditional principles before this invention of the reinforced concrete of the 19th century, it's almost global, the whole civilization using the same principles and the local material to build a fantastic example of the architecture. Here I welcome everybody, and I want to start present what I'm trying to do and what we did here in Jordan. Before I start, I have to talking about the master Hassan Fathy, which is well-known architect, and he is the one who revived the culture, our architecture and cultural heritage he revived it and put it on a new project and make it in like a beauty way. That's make the whole world looking to what he did. And he has also a lot of disciples work with him, like my mentor, Professor Abdul Wahid Al-Wakil. Here, I would love to share some projects of Hassan Fathi before we start. Uh, this picture, I think, in India, when they are getting the Aga Khan Award, Hassan Fathi on the left, Al Wakil at the middle, and Uncle Ala, which is he the builder. They are insist to bring him and also give him a part of the prize. One of the uh, incomplete project for Hassan Fathi, which is uh, Paris Village. Uh, this is like a really big project on urban scale. Some of the project already has been complete and built, but the rest of the compound, which is contained like schools and so commercial districts, residential for farmer, for non-farmer farmers, a lot of parts of the village are not completed. Here, this is like a close-up to what we have. 1, 2, 3, 4. Some of the project they are completed. The rest is not yet. Here, there is like original sketches from Hassan Fathi and some instructions about the courtyard and the ventilation of the how he imagined that city. Some of the project I start even uh, uh, draw it on computer to understand and feel the module and his way of or the design principle, what he is trying to understand his work. You have to draw it. Here we can see some of the center of the village on the left, and some samples of the housing and how he can play with the form using that internal courtyard and small street in between. Here also some sketches, original sketches from him. Then when I learning Hassan Fathi, when I'm looking to the floor plans and the sections elevation, I saw the drawings are very simple, and you must to build that uh, project on the 3D computer to understand the levels and what's happening in the ceiling and what's the relation between the walls and spaces to understand the form. So on this example, this is like a from 1980 house design. It's very simple. You enter from here. If you see my mouse, uh, we have an Arabic Ka'a, which is like a sitting area. And the right wing is the living and bedrooms are on split level. You have a stair here, you're going up and going down. You have the bedrooms, the bed under the vault, and the room itself, it's like a sail vault or shallow dome here. They have like a sunken, not sunken, but at the lower level courtyard and loggia overlooking to the pool. On the right side, you can see the lower level, the stair going down from here. You have the courtyard at the lower level. This is some drawing I extracted from that drafting of from the model itself, some sections, elevations. Here we have an original floor pattern from him. And maybe on the left, there is like an alternative previous design, not the one which has been built. This is the images of the project. There is a few projects of Hassan Fathy built by stone in Egypt, most of them out of adobe and brick, mud brick, but some of the projects built out of stone, like this example here, depends on the location of the house and the surround material. Here, I'm showing how, after I build the model, I can extract some 3D images from the model. This is the exact design from Hassan Fathy. We can cut on the model to understand the relation between the movement of the forces from the ceiling. You can cut the plan to understand the levels also. Some nice shots. Then I have to go to talk about Abdul Wahid Al-Wakil, which is he's well-known architect, still practicing until now based on Qatar and UK. I work with him on 10 of projects, maybe more than 40 projects, and until now we are still working on some projects. He is one of the disciples of Hassan Fathy, and I stay with him like 10 years. There is no single day he didn't talk about Hassan Fathy. He's really, until now, daily he remember him as a master. And when here I will explain also some of his projects. This is the Oxford Center of Islamic Studies on Oxford, of course. There is a mosque and auditorium, courtyard, rooms, classrooms, library, dining hall. It's a really big complex, and we can see the architecture language matching the area. He brings some English details like to keep the project matching with the surround buildings. Maybe the minaret's not tall enough, but that's, I think, from the regulation, what they have there. We can see here this rectangular shaped window with the true arch above to keep the straight lintel, courtyard. Here, the second project is King Saud Mosque, which is a very big project in Jeddah, Saudi Arabia. He has like a 20-meter diameter dome, brick dome, all of this structure out of fired red brick. This image during the construction, we can see the size of the project and the number of the domes and the size of later on here at the middle, the main dome. Here another image during the construction. And on the right, we can see also Al-Wakil with the, I think that's Javid Gel on the right. Here, this is the main courtyard, main dome on the left, on the right. We have like another 4 E1s connected to that dome, similar to the design of, I think, the Sultan Hassan Mosque. We have central courtyard open to sky with 4 E1s on each direction, and then you have the dome of the prayer hall. Here you can see the laborers on the right building the dome after finishing the squinch level. On the left, that's the details of the dome from the interior. Here, that's the profile, revolving profile on the center. On the left, we can see a formwork of fan vault. That's the image of the main dome after completion of the project. This is another big project also, which is Masjid al-Miqat. He has a really huge construction site, all of the site out of brick, of course. We have the mosque at the middle, courtyard, inside the courtyard, and the ablution and the toilets, because this is serving Al-Hajj Road. So we have a really big number of services all around. And the minaret on triangle plan, similar to Ibn Tulun minaret in Cairo. These images from Al-Miqat during the construction. Another project, which is Masjid Qiblatain. This is the image after the construction. Here, Quba Mosque after finished. Now I will start present my work here in Jordan. So after working with Abdul Wahid Al-Wakil and Hassan Fathi, affect all of my thinking and converting to like a traditional architect. When I start working here, I go against the reinforced concrete. I'm trying to use the stone, which is the available material in Jordan. And this is the first project. It's a small house with a small courtyard and Arabic Ka'a, which is the main dome at the center, dome on squinch, with two E1s, right and left vaults. And I'm trying to build a different type of vaulted ceiling to learn and understand how is the behavior of the forces when we are using the stone material. Here we can see the main qa'a plan and section, top view at the drum, and isometric here or bottom view to see the here one of the longitudinal section to see the qa'a and the relation with the other part of the house. On the right, we can see the visualization and rendering before we starting the project. This also 3D visualization of the main qa'a, some oriental details. This is the upper part of the dome after we convert the square to octagon shape here on the plan. And this is the actual image during the construction. Here we can see the 4 squinches before we finish that part of the drum. Down you can see the scaffolding at the square of the space, which is still square. Then we have to convert the square to octagon shape to easily rest the dome above that shape. This one during the construction. Here, I'm trying to explain what we are using as a material. This is all stone material. I have tried a lot of type of formworks. This is one of them. We're using like extruded polystyrene to carry the arch or the vault before we finished and put the key and removing the extruded polystyrene. This is the bottom view. Where is the red line? Here is the square of the space. Then we change that or convert that red line, which is the square, to octagon shape, the red one. And we can see the squinches at the corner. Then from the octagon, we have a 16-fold side polygon. So we have this piece here to convert the 8 to 16. Then we can start build the dome. This piece we can see it here with this shape, and the interior looks like this. Most of the stone I use it from the excavation. When I excavate the land, there is a we extract more than 1,000 cubic meter of the rocks, so we use it. Here, different part of the construction. This is a cross vault. We build the 4 arches first, then we have here on the lower left the scaffolding to have the cross vault, and then rest the stone pieces, always perpendicular of the curvature. And this is the outcome at the end. Here we use like a very, very light formwork, which is only a steel bar. We put 2 of them and construct these big pieces of arch. And we have this manual crane, electrical crane. After we release and put the keystone at the middle, we can easily remove this formwork. So it's not expensive, because even the steel bars, we can reuse it again. This is different type of arches during the construction. Here I'm showing the stair, how we build the stair. We have like a pillar on the right, then 2 arches, and the stair steps rest on that half round arch. And this is the result. We close it in the middle. But here on the left, you can see the whole stair structure based on 2 arches. Here I'm showing the shallow dome or the sail vault, how we construct on site. If you have like 4 sides of that square, you have to build half round wall on each side. Then you will start closing the pendentive at the between those half rounds. So here, before we close the sail vault here or the shallow dome, we have to build 4 half or semicircle walls. Then we close the corner. Here, that's the guide rotated from the center. And also we have like a outer guide to minimize the thickness of the section of the dome itself, starting like thick from the base, and then it comes smaller. Some of the technique we made like cut a stone wedges, which is we are used like the stone available on the market here for cladding, which is like 5 centimeter width. I tried to use it for the vault itself, so it will open from the outer radius. You have to fill it and adjust it by those stone wedges, and it's like a very easy way of construction. You can finish this vault like 2.5 meter span by 4 with maybe 2 labors, like 2 or 3 days, easily to finish that vault. Here we build the vaults for the qa'a, the right and left vault, before we start building the drum of the dome, to use the forces, the thrust forces coming from the 2E1 right and left. So we have to finish it before start building the dome, to push the other forces, the other thrust forces coming from the dome, and make the result within the wall thickness. Here We use the lime to finish the vault from outside. Here I'm trying to, on one of the spaces, we have intersected vault. So we have one main vault and intersected by four small vaulted. And this is the image after we finish the construction. And this is the interior of that space using two different type of stones also. Some of the ornaments and carving stone pieces, I did it myself by chisel and some uh, electrical tools. Here also the tile pattern, we use some patterns from our cultural details. So here this floor pattern, we used three type of or three colors of stone, which is the basalt available here on the market, and the yellow is the travertine, and we have normal white stone or off-white stone. All of them like a local materials. We cut it on the side and prepare this kind of floor patterns. That image from one of the upper window on the right, from the dome, looking down to see the qa'a and the tile pattern on that. Inspired from also Al Sultan Hassan and Cairo, the floor pattern. Here, this small bedroom, we have the bed under the vault, and the room itself is a sail vault or shallow dome. The seat are built in, the closet are built in also. We have those niches. This is the outer courtyard also with floor patterns. It will give like a life to the space with those colorful patterns. Some ornaments for the arch. Here we can see the main dome with the two vaults, main qa'a, right and left after finishing the dome. Some details like a stalactite, muqarnas. This is two rows of stalactite. So I have to draw it on computer first, then draw that elevations on the stone itself, like front and side. Then we cut it by chisel and grinder to get that stalactites. Here also some floral pattern, which I try to, when I have a free time, I go to that, let's say, column or part of the wall and do that on site after we built it. Another example I did in Jalad area, which is another area in Jordan, Salt. We have like a very big drop-off area with the entrance canopy here. So we did a cross vault at the entrance. This is the car coming from here, and this is a drop-off. Underneath, we have like 8-meter span cross vault, which is big one. This is the formwork before we start the vault. Here you can see the stone raised on that formworks, and this is the result after we remove the wooden shutter. And here the span, I told you, is a big one. I couldn't sleep before we removed the bolts because I'm afraid, of course. Here I did like a real corbel with twin columns. This details comes out because of the sometimes there is a modification on site on the design. That modifications, it will uh, bring the project to another way. Before we have like a column at the middle because I'm afraid to have the 8 meter span. Then the client asked to remove the column. So what I did, I put another round column with corbels to minimize the span a little bit to get like at least 7, 8 meter span. Then I have this cross bolt. That's the space. And we have like double volume here at the entrance with high ceiling vault. We did also with marble this time, some tile patterns. This is during the construction at night. We are testing and seeing what we can do with lighting. And I brought on this project architecture students from the university. They work like 2 months on site and help us on um, cutting the marble for the floor pattern, building the vaults, and they are really uh, like the work on site. Then another image here, bottom view showing the opening, the opening and the upper vault. What else? This is the student during the construction and during the cutting the marble, doing some floor pattern. Here they are cutting the tiles, some decorative pieces of arches. Those pieces I cut it myself. Here, cell showing some tile patterns during the construction. Here we can see the cross vault also at night. There is another house, farmhouse on Jarash, which is also like a historical place near Amman. We did three centered arch vault. Like this arch, we divide the span to 4, equal 4. Then from the first center, C1, we draw a circle, cut it from the 60-degree going down, repeat that from the left center, and the intersection of that 60-degree cutting, you will get the third center down to get a smoothness of quadrant um, uh, connection between the two arch. So this is the result. Here we used a big, wider stone pieces. The entrance porch, this is the only additional element. We have twin column and some stone stone arches pieces with ornaments. This the same room before we were removing the shutter. This is the construction technique. That's the stone structure. We have a swimming pool, of course, not out of stone, but the arcade around and the tile patterns. I've tried to cut on each art different way of ornaments to see the difference. Here, like small triangles, here another details. So every time I'm trying to see what's the easier way or maybe more beautiful uh, output of the art. The third project or the here explained, this is mosque of the blessed tree. It's far away from Amman. It's like 160 kilometers, which is there is a blessed tree. The tourists and they are coming to visit that tree. So we built like a mosque there. It's very simple mosque. We have three domes. At the center dome, we have dome on squinches. Between the domes, there is a vault, pointed arch, 3/5. And the small domes on the right and the left, which is shallow dome or sail vaults. The wall thickness almost 1 meter. So we have this niches to minimize the width of the wall. We have buttresses here at the end of the main dome. At the corner of the walls of the main dome, we have those four buttresses, and this is the entrance. Here, this section through the mihrab at the end and the dome on squinches. This is the part of the domes. Here on the graphics, on the design, during the design process, from the lower right corner, that's the plan. You then go up to see the cutting still on the two domes and the squinches until the four windows here, and that's the top view. This is the longitudinal section. We can see the sail vault on the left and the right, and the middle dome on squinches. Another sections, I just, from the computer cutting on different levels to see what's the, how the section looks like. And this is the a 3D visualization before we start. And this is the result at the end. On Qibla direction, I have those two buttresses, right and left, and mihrab. Then we have the dome with those two or three steps, putting some triangles at the corner, imitate the minarets, because we don't have minaret on this mosque. It's a really small mosque. Here, I add some pictures about the construction technique. I divide the wall to two segmental arch to minimize the span and also make the wall stronger. Then after those two segmental niches, I built the wall with semicircle shape to construct the shallow dome or the sail vault. So here we have the three and the fourth one at the back. Then we start to put the build the pendentive to close the corners. This picture, you can see the half round walls, and we built here the corners, which is the pendentive, to get at the end a circle, totally circle, touching the quadrant of those four semicircle walls. Here, after we finish the project, you can see the shallow dome overlooking the other side, the recessed or niches with segmental arch and middle window. details. On this picture, we can see the squinches, which is carried out not on stalactite, but like a cantilevered angles, triangles, big stones going through inside, one above each other, to get the octagon shape. And here, this is the squinches and the mihrab uh, elevation side, the entrance, and we can see here the squinch carried on those three level of stones. After we finish those four squinches, put twin windows in between and get the uh, circle layout and uh, start building the dome itself, putting also this guide rotated from the center, and the builder, he can move that guide on every layer of the stone. The brick domes, it's easier to build using only just a guide, because if you build with red brick and put cement, the red brick will stay strong and keep the place where you put it and dry fast. Also, the adobe, when you are using the mud, it's easier to close the dome. But here, the upper third of the dome, it's not easy because this stone, it's not stacking with the mortar, and we use silica with the lime. So what we did here, we invent something to have the upper part of the dome as a foam uh, formworks. So we hire the scaffolding to that level, which we couldn't complete or continue the construction, and put some sand and foam to get that. Here on the right, you can see we put like a sand above the polystyrene. And after we finish, just we remove the shuttering, everything is fall down, and we keep the dome from the interior clean, because the sand easily you can remove it. This is the image after we finish the main dome. Here you can see how we start from the square on the plan with those three levels to carry the squinch. Also here at the middle, like 3 steps, twin windows, another 2 steps to convert the octagon to 16 side polygon. Then we have another 4 windows and rotate the dome. This is the dome from outside, from the roof. Interior shots during the construction. This is the entrance vault here, entrance porch. We can see also the rainwater drains exposed from the wall, also out of stone. We did some tile patterns with uh, black basalt and white local stone. And also there is two universities send some students and visit our site during the construction, and they get fun. We allow them to cut the stones, cut the rocks using the wedges, playing with the lime. That's it. I couldn't hear you, Georgia.
Can you unpin yourself? Okay. So now we can see our invites. Thank you so much, Maher. It was fantastic. What a journey. I am totally transported in this world. We are starting now the session of question and answers. So if you have questions, please unmute your microphone and ask directly your questions. We have one, but that's about thank you. So if you have something to ask, please
I want
ask.
to ask Simon about your opinion.
Simon,
Well, yeah. I wanted to. I've got several questions, and I want to congratulate you on your the sort of heritage that you've sort of drawn into it, and in particular your hands-on nature of actually doing some of the stonemasonry and carving yourself. Could you first tell us about your background and how you managed to get to be a lot of architects, which annoy me, can do a drawing and have someone else do it, but to actually be able to do it yourself is quite a rare thing. And where does that come from? Do you have a background of working in stone and craftsmanship yourself?
No, actually, I told you in general previous, I'm an office guy, architect. Then mm, I do some supervision visits during the work with the Professor Al-Wakil, but I didn't build myself. Then when I start this experience in Jordan, I'm trying to do like, which I saw some ornaments or carving on the stone, so I couldn't find a craftsman to do that. So what I did, I bring the tools and start doing that myself. And maybe within 1 month, I become a good craftsman. And all of these ornaments you see, and the arch cutting, the stone cutting, the some decorative elements, pattern, calligraphy, all of them I did it myself by my hand. And it's not very hard to learn that, because when you are coming to cut the, let's say you have a different type of pieces, you have the knowledge in your head how to cut that piece of stone to get the shape what you are looking for as a stalactite piece or whatever complication of that piece. So it's easy, you draw direct on stone, and you learn how to use the grinder and cutting, and then with the chisel. So it's really interesting. During that construction time, I work from early, like 6 a.m. until 6 p.m. Then I back home just to sleep. I didn't do anything, eat and sleep until the next day. And when you work on with your hand, you feel happy more than doing the administration work on the office itself.
Mm. That's amazing. Yeah, I mean, I think more architects should get hands-on because you also get a feel. A lot of architects, well, I meet builders that have architects telling them what to build because they say they've done a drawing that's unbuildable and it's the builder's responsibility. When you actually understand the material yourself, the builders will have much more of an understanding, and you will also have a much greater feel for the sequencing and the kind of the feel for the material. I think that's where it really kind of comes back together, which is we used to have this thing called the master builder concept back in this country before an architect was really this profession where, you know, the design and the making was all joined together. And that's where architecture sort of lost that. And you seem to be bringing that back to being a much more holistic thing.
Yeah, and this kind of construction, like if you are trying to build something, you're going to on the market and search on the contractor. Nobody has that experience to build what you are dreaming of. So you have to build a team and teach them, and using your the know-how and your experience and your hand sometimes to explain to him. So there is no another way to do that. there is no local contractor available to build a traditional construction building, at least in our area.
Mm. We've got a lot of questions. I mean,
Yes, a lot of questions.
is it-
Aber,
yeah, it's all right
you
if
would
I
like
I
to-
can probably start weaving some of them together. So, can we talk a bit about cement versus lime? And I mean, some of the questions about is it economically viable to build such buildings compared to, say, doing it in reinforced concrete? I noticed you mentioned lime. I think you also kind of alluded to the fact that you do use cement in various parts, and just wondered, obviously with traditional restoration, which is another question, really you should only use lime and matching materials. In modern construction, obviously, you don't have that restriction from a conservation perspective, but you still might have it from a perspective of actually being really traditional and having that ability to be flexible and to move. So perhaps you can talk a bit about cement versus lime in your work and within perhaps conservation as well in your region.
The lime need more time to curing and to get to get the CEO from the air and get hard. So what we are doing, we did different trials. First of all, we are building the walls itself by black cement, normal cement. Then we mix the lime with white cement for the vaulting arch and any vertical any ceiling type, because it's easy to clean it, and sometimes you don't want to put a lot of effort to have that white joint between the stone. So yeah, the walls still, I did the walls with the black cement, but because the wall is very thick, we are using on the, let's say, the outer and inner facade like two big pieces, dressed walls. So at the middle, we don't fill it with the concrete or with cement. We put the small pieces of rocks, which is coming out after we dress the stone itself, and fill that cavity with the small pieces of stones and rocks. And then we put like a layer of cement to get easily to build the second layer of stone to rest easily and to work faster.
Aren't you concerned that in time the stone will get eroded because it's weaker than cement? Because this is the theory of conservation. You use a brittle mortar to prevent stone to collapse in time.
Yeah, but also the lime by time, like 100 years, it become stronger than the stone itself.
Yes,
because
but still breakable.
Yeah.
I don't. I mean, yeah, you don't have the problem of weathering. I mean, in terms of yeah, in England we have a lot of rain and a lot of damp and very wet walls. You need the joints to be the most porous element for sure. So I suppose your climate's a bit different to ours, more
Forgiving.
sunshine, but yeah,
Yeah,
but
different.
yeah, do you have-
Well, sorry for we use for all the exterior joints only lime with silica. Then after that, directly we spray it with a soap liquid coming. We did it even at home from the olive oils. So that's make the lime preserve more of CO2 and become stronger, easier. So we don't have like any black cement on the outer facade.
Mhm.
So that's like a tadelak, the technique.
Yeah,
more.
Tadila.
Yes.
That's from Morocco.
We have a very interesting question from Aber and also from Mohammed. can you unmute yourself? Can you unmute Mohammed, and then we will take a question?
Yeah. First of all, thank you, Georgia, for inviting me. It was a very interesting
You're very
email you sent me.
welcome.
And
I'd like
sorry.
to present him. He is the chair of Inbau Levant.
So again, thank you, Georgia. I've been off the INBAO members for the last year due to the events that's happening in Lebanon. So I'm not quite active. But I just was with you in the Philippe Rotier last month, but just on Skype. And thank you for introducing me, Maher. So my question for you, Maher, it's always very interesting to see how, first of all, you introduce yourself as a disciple, a theoretical disciple of Abdul Wahid al-Wakil and Hassan Fathy, and you have practiced with Hassan Abdul Wahid for the last 10 years. And Abdul Wahid is a friend of mine since like 20, 25 years. My question is maybe more general, so other people would understand, and I would understand the nature of the practice, not only for you, but for any new practice that's starting building with traditional material all over the world. I'm interested in two things. First of all, on the professional practice. And so my question has twofold. One, the professional practice, and if how you started, and if you have difficulty in getting approval from municipality, and because the most of municipalities do not understand the construction technique, and they would ask for calculation method. Abdul Wahid had the same thing building the Islamic University in Oxford. He had to present some calculation in order that the permit was given. So first about your professional practice. And second, when you go to construction, is it difficult in the area to find the stone makers? Because like Simon said, you're basically not an architect, you're a builder architect. You do both the design and the construction.
Yeah.
So if you can, and thank you again, Georgia, for introducing me to Maher.
Yeah. Actually, Mohammed, I saw you many times with Al Wakil in Beirut, and
Okay.
last time I met you when Samar Damlouji signed the book.
Ah, yeah, and Surso Museum.
Yeah.
Yeah. Sorry,
It's okay. About the regulations, actually, the regulation on our municipalities here, or I think all of the municipalities where I just practice on the Gulf countries or other places, they put a kind of regulation that it will not allow you to do a really good traditional or urban nice architecture design. So here, even the plot coming small and small and small, still they have the regulation to get a setbacks from four sides and build the house. So on floor plots like a 500 square meter, and when you get the setbacks from four sides, you have around 200 square meter. You couldn't put any court. So if they allow you to cancel this setbacks built at your plot at the edge and keep the let's say 50% or 40%, they allow you for the floor rent, keep it at the middle, you will get automatically a courtyard. So
no, Maher, maybe my question is that
for my experience here, when I'm trying to get the license from
yes,
the
yeah,
permit, they said we don't have any let's say department to check the load bearing calculations, and we're not allowed this kind of construction. So you have to bring us a reinforced concrete and the convention or the what they are used to have. So what I did, I make a normal concrete house, put four columns, flat slab with reinforced concrete, and submit the paper to get the permit. Then I go and build whatever I want. And now we are at the final stages. We will face what I don't think they will demolish the house, so we will give you a fine or something like that.
And my second question about, is it easier in the country to find proper builders? I know in our part of the world is much easier than Europe.
It's not easier. I did it with 2 teams. I brought like normal carpenters. They have experience with all of the life. They have experience on the reinforced concrete. Then I use them to build step by step this kind of construction. The second guy, he has experience with stones, but let's say he never make any vault or any stone ceiling. They can build like a retaining wall or normal wall by stone. But in general, I use normal carpenter. They never touch the stone, or they never built any curve or any arch, true arch by stone.
Maher, I think what's sorry, Georgia, like I'm eager to ask some questions for Maher. First, it's very interesting because you went back to your homeland, Jordan, and you're getting students to participate and understand this activity. So you might do eventually you could be able to get more clients and students to understand. Maybe the best is go and to teach in some of the universities other than also to bring them insights. Because most of my practice, like Abdul Wahid, working in Saudi Arabia, and also maybe, Jarudi, he has built a couple of projects in Saudi Arabia, in those remote countries where it's very difficult to get architects to learn that practice. I think you're good placed now in Jordan, and I hopefully through getting students from universities and get in touch with municipality, you can get some movement there, because Jordan is not far. The construction, I know that Jordan has excellent stone makers, but it's just building facing. But I think the way you're working with the practice, eventually, I think you'll be like a key figure in the area.
I did my best. Maybe during the past 5 years, more than 5 or 6 universities sent a lot of students repeatedly on the construction side and stay with us for days, sometimes stay like 2 months at the summer, and using the hand to work on that. And they are very happy when they are cutting the marble, cutting the stone, building a small arch. And because still they are young, like on the university, they open the mind, like what you say, to have there is something different and different in the way of the construction.
Maher, thank you very much for the presentation. Thank you, Georgia and Simon. I will give the others some time to ask you further questions.
We have a different type of questions about the environmental management in your constructions. Aber, if you would like to open your microphone and ask directly the question, would be great. I hope she's still with us. Aber, do you hear me? If yes,
Yeah, I'm here. How are you?
I am very fine, very happy to have you here. So
Okay.
can you ask Maher directly your question? And
Actually, it's a very interesting presentation, and I was a bit amazed of. I was like looking at the buildings till the last stage as you were like presenting them, and it seemed that most of those buildings were lacking any installation for any active cooling. So I was asking if those buildings are merely rely on passive cooling, natural ventilation, or you have installed those air conditioning systems later on, but they are not really shown in the photos.
Actually, Abir, because I don't finish at least one project to make the test after we finish the project and use it. So what I did, I put a provision, to be honest, with the copper pipes. So on the calculation, the ventilation, the thickness of the wall, the breathable walls,
Yeah.
it will give you, it should give you like a difference at least 10 or plus more than 10 degrees in the summer and in the winter. And we can feel it. Yeah. Now, even some of the construction sites still not totally closed, but we can feel it once we have a snow on that on Jordan. So it's freezing and snowing. We get inside one of the walls, so we feel very warm, really. And on the summer, the same. You coming from outside, at least you feel like there is a 5, 6 degrees different, and still the site is open and not finished. So, but what I did, I put like a provision copper pipe to have an air condition on the future.
Okay, yeah.
I prefer to not install any of them and stay green.
Yeah, 100%. But have you ever studied the cooling effect of those stones in the building? I mean, if you've done any comparison with the concrete buildings and those stone-built structures, and to compare the indoors temperature.
We did studies by others. They calculate the thickness of the wall. Let's say you have 75 centimeter or one meter width of the stone wall. They say it's not equivalent to if you have like a normal concrete, two small thin walls with insulation inside. But that calculation, because it's comparing only the material and the thickness of the material, they are not putting on the consideration the height of, let's say, this dome or this room height, 10 meters, and have like a 16 window openable at the top, so the hot air can go out and you have ventilation. So they don't have let's say, on the system or on the software itself to put these these factors of ventilation on the consideration. So we have to try it after we finish that project.
All right,
Yes.
thank you so much. Yeah, that's really good. Thank you so much.
Very good question. And I was wondering the same, how much you use practically from the traditional passive means of environmental management, because it was a real tradition in your area of using the natural forces, the winds, the difference of height, of temperature, all those details. But probably after you finish them and you start doing some tests, you will realize yourself how this really works.
Yeah. Also on the gray water, and we have like two types of drain. Some we will use it for irrigation, and we did some solutions, but like what you said, we have to test it to give later on some really figures to compare.
Yes, we will take now some questions from Claire Littlejohn, who said that she traveled to the site to see your work. Claire, are you there? Can you
Hi, yes, thank you so much. This is absolutely fascinating. We've just traveled to Iraq visiting Samarra and Hatra, and went ultimately to Mosul and saw the destruction that had taken place in Mosul. And it was heartening to see them on a UNESCO project rebuilding the minaret with traditional techniques. But it did look like when they were starting to rebuild the city in Mosul, that traditional techniques weren't being used to make the beautiful domes and arches in all the old houses that we saw destroyed there. And in fact, visiting Babylon as well, it was rather disappointing to see that it had been rebuilt with modern techniques. And I just wondered, I'm involved in heritage architecture, and I just wondered if there is any mandate from UNESCO to build in a more traditional way. And can I just say it's absolutely wonderful to listen to Mayor and the way he builds, because it's fantastic.
Thank you, Claire. I graduated from Mosul, by the way.
Oh, fantastic.
Yeah. And before, I think there is a competition for building the main mosque, and I don't like the chosen project. I see it like something could be in Dubai or different city, not on Mosul. Mosul is very traditional city, have an old downtown with a really landmarks, architecture, churches, even you can find some mud brick structure from maybe 3,000 years ago, still standing almost.
Yes, but there was very little of that left. I mean, the only thing we saw really was around Samara. Many mud brick walls left there. In a lot of the sites where there had been damage, there was rebuilding, but using reinforced concrete, which seemed to lose the magic that the old streets previously had.
Georgia, can I answer Claire?
Yes, please.
Georgia?
Please do.
Yes.
Yeah,
Please
Georgia.
answer, please. Yes.
Yeah, Georgia, I've been involved in Jeddah Historic City, which is a UNESCO conservation place. They have 700 buildings of traditional buildings. And when we came to design to rebuild the city center, we did use the same technique that have been used in Jeddah. But unfortunately, we had ECMOS in the group to review, and they said ECMOS that they had no problem for using new construction method. And I asked them, what is the new construction method? And they said it's concrete and steel. So there I was a bit, astonished to see ECMOS giving us approvals to use concrete and steel in sites which is like 800 years back. And I think in Bao, especially Robert is doing some work, and they had like a big gathering in Venice just to change the ECMOS report and say using traditional sites have to be reconstructed or added with the same construction technique, because there were problems in Spain where after the earthquake, churches were been restored in concrete and steel. And then when another earthquake came to them, cracks happened between the old building construction and the new building construction. So I think this is something that it has to be reviewed by UNESCO and ECMOS, and how to say that, no, we cannot use new building material in old sites.
Yes, thank you, Mohammed. That's very interesting, because I traveled to Iran and have an interest in the dovecots around Isfahan. And there we could see where they had been repaired with modern fired bricks. And actually, when there was future damage, the future damage seemed to be centered on where the repairs had been done in modern techniques rather than using the adobe bricks to make a repair.
Yes, I would like to add something to what Mohammed said. Indeed, Inbao had long time ago a revised Venice Charter, and now there are 20 years since it was released, and we are planning with Matthew Hardy to have a revised Venice Charter, because a lot of things changed meanwhile. And we have somehow to challenge those interventions with modern materials, which are contrasting with the existing fabric, because from this point, a lot of problems start. not only aesthetical, heritage related, but also, as Claire said, the new materials are of different quality. They don't behave like the historical one. And from there, you can practically compromise the full structure if you don't have a good binding of the old and new materials, or at least to behave on the same way. And in Inbau, we are working on this. We will have next year, TAG, our organization, will have a conference on conservation and how the conservation works are addressing new traditional architecture. And this is part of the discourse that we have somehow to challenge this Venice Charter and somehow to bring back those two professions together, new build and conservation, not to be such a schism in between them, because this is abnormal, it's artificially created. Ricardo, you had a question about the economically viability of those buildings. Are you still with us?
Yes, of course. Of course. Thank you. Do you hear me?
Yeah,
Yes,
yeah, we
very
hear you.
well.
Okay, I wanted to ask if is it economically viable for Maher to develop such buildings with such exquisite details and stonework, or do you need some kind of subsidies to fit into the budget?
Here, especially in Jordan, the daily labor cost is very high. You cannot get any labor less than $40 per day, and you have to provide him with the transportation and food. That's the normal labor. Any skilled labor starting from $50 per day. So if you look at our region, if you go to Syria or Iraq or near Egypt, the average of the labor cost is less than $10 per day. So in Jordan, that it will increase the cost, because here we don't have a ready mix concrete to give him the money. Only you have this rocks coming with actually no price. When I finish the excavation, we have, I told you, like 1,000 square meter, cubic meter, sorry. So I just go around and find another construction site. They have a lot of rocks, and by law they have to put it out of the city on some special place, and they will pay a lot for transportation and removing that excavation material. So I just ask him to put I choose some nice stones and rocks and put it on the side. So you can bring like a truck with 20 cubic meter here in Jordan by like 20 or $30. It's nothing, the cost of the material itself, because it's available. So what is increasing the cost of this kind of construction is the labor cost. And because you don't have also a craftsman, you have to teach him and learn them. Like from my experience, let's say the first vault I did it took me like 2 weeks. Then after that, within 2 days, we did bigger than that vault. So if you compare the cheapest concrete floor plan area to this kind of structure, this is more expensive, of course, because also we are not comparing apple to apple. Here the height is different than the normal size of the apartment, which is like a 3 meter height only. I hope that's answer your question, Ricardo.
Yes, of course. I had another small question about your vault making technique with wedges.
Yeah.
Do they come in contact to each other in the introducts of the vault?
I did the vaults in maybe 2 or 3 different techniques. First of them, similar to this vault on the right, which is I'm using the cladding stone material available on the market. So here on the market, this one used as a cladded material. It's a standard height 25 centimeter or 20 by the thickness of 4 or 5 centimeter and variable length. So this kind of stone, it's available, and you can, let's say, for example, this vault, I brought the stone, and within maybe 3 days we finished that vault, because just only we are putting above the formwork that stone perpendicular and putting that small wedges, and then we fill it by white cement with lime and make it rigid. The other way of construction to make the vault by dressed stone, and that's required more skilled labor to do that vault, to keep the edges like tilted a little bit, so the stone itself, but if you put it on pressure, it will not fall down inside after you removing the shutter.
Okay.
Thank you very much.
Thank you.
We have a question from, I don't know how to pronounce it, Abd Al-Herm Al-Zen.
Abdurrahman, yes.
Yes.
Thank you.
Maybe it's a abbreviation, right?
It's fine. No, it's my full name, but it's a bit it's normal. I face that everywhere.
So please
First of
ask.
all, thank you. Yes, thank you, Maher, for your beautiful presentation. I want also to take this opportunity to greet Professor Muhammad Hamawi. I was lucky to attend one of his courses at the Lebanese American University, and he was a great inspiration for me in seeking this path in traditional architecture. I wanted to ask Maher about the wedges and the vaulting technique, but Ricardo already asked the question. But maybe I could ask maybe further more details, like how did you manage to verify it structurally, because the stones seem very thin. Did you do any experiments, or did you maybe do any calculations concerning this new technique? And thank you once again for the beautiful and inspiring presentation.
Yeah, you are welcome. There is a rule of thumbs for the structural relation between the width of the wall and the opening span. So this basic calculation, I used maybe more my sense. After actually in opposite, after we finish the project, I make a calculation in software called Diana for structural for structural analysis, and give you the evaluation of the loads, and that used by I think people more related to historical renovation and treatment. One of the colleague, he did that, and the result was really fine for the thrust and for the forces. But in general, like when you have a span, you go by 1/5 to get the width of the wall. So if you have another vault coming from the other side, it will easier coming smaller, because you have two forces coming opposite of each other, so the result will goes down.
And is there any live load going to be like on the top of these vaults, or is it just a ceiling and a roof?
No, there is live loads. There is also here snow on Jordan. You have to calculate at least 1.5 meter height of snow, but not on
Great.
this mosque. That area on this mosque, there is no snow there. So we did that
Great.
calculation, and we are pass
Beautiful. Thank you so much.
Yeah.
Yes, I think if those calculations would be somehow more regulated, it would be easier to have this type of load-bearing stone walls and construction
Yes.
approved, officially approved.
Yes, of course. Actually, when we did like a big size domes and big project with Professor Abdul Wahad, we did that calculation before we start the construction, and we put that documents before we start, and it's done by specialists. We know a good architect, structural on Turkey. He do that for us, and also there is another guy in Egypt. So there is like a structural engineers specialist on that load bearing calculation.
So in this case, we have to train more engineers along with more architects, craftsmen, because only with them we can really build legally, and that to be like good practice, not just sneaking some beautiful buildings in between concrete buildings.
If you want to get this one regulated and even help the architects or the clients need to get this kind of project, give him some not only the calculation or approved, give him some tricks from the global experience, how to solve the seismic issues, how to solve the waterproofing issue, how to solve the get more ventilation to the building. This kind of like a manual, it will help a lot.
Yes, this is an idea that we talk a lot lately in the INBAU meeting, to create like a technical committee where all the chapters to share their knowledge and to help each other, because in some countries you can build on this technique, in other countries you can't, and at least to show the positive example and to show, you see, it's possible, it's approved, why can't we either? Spain has the same problems, but not in all Spain, just in some regions. In some it's approved, in other it isn't. We have another question from Abdullah Al-Sokotri, which somehow would summarize what we heard here. Are you here with us? Would you like to ask the question, Abdullah? I don't see him to engage. In this case, Simon, if you have another question.
Was going back to your structural thing. You used three-centered arches, a lot of traditionals. You also use catenary arches, I noticed in one project, which reminded me of Gaudi and his models using chains and little weights. So he hung them, and then you build the reverse, and it automatically stands up because all the loads transfer. And but it was more about just the setting out of arch. A catenary arch is not so easy to set out on site with shuttering, because you're not just using a radius and then rotating it. So is that a more complicated thing to do on site, or how do you do that?
No, actually, when I did this catenary, it's already written by like equation to have a real shape of the catenary. But what we did is the simple. If you have like a span, check the semicircle or half the parameter of the circle, the length, calculated from by calculator, which is by 2 by the parameter. So I bring a chain, the length of that chain, the half of the semicircle of the radius of the circle, and then I fix it on the like a wooden plywood sheet with exact span what I have, and then it will fall down and draw the shape of the catenary. I mark it on the plywood, cut it, and use like 2-3 pieces of them, put the wooden log at that shape and get the catenary.
Excellent, very simple, very elegant. Thank you.
Are there any more questions from the public? Anyone wants to ask?
Yes, can I ask a question, please?
Please.
Firstly, thank you for the presentation. That was a real joy to watch. I wanted to ask about the foundations. What materials they were made out of? Was it also stone?
Yeah. Oh, sorry.
No, go on.
Yeah, about the foundation, the first project, I make it like a reinforced concrete strip footing. The rest of the project, I make a strip footing by rocks stone itself. So because I was afraid at the first project, the second, third, and I did 5 projects. All of the footing is strip footing stone. That's it. Especially when you have like a solid rock, you reaching the natural ground. And here our land, if you go down a little bit, it's like a solid rock. And
so you have bedrock underneath?
Stable, yeah, stable.
Okay, all right, thank you.
Yeah, you're welcome.
So Abdullah, if it's here and want to ask his question, otherwise I can read it. And he said like that, the project is very inspiring, but everyone is asking how we can go back to all those lost techniques. I think that's what he's asking. So practically how we revitalize the traditional way of building, continuing what your master started. How do you plan to spread that?
Yeah, it's very hard question. Actually, when I start build, let's say this one, I'm good in computer, 3D, I can draw stalactites, complicated geometry. But when I start working on site, I want, let's say, to do a cross vault. I search on the net, on the YouTube, you can find a picture of cross vault, but how you build it on site, on video, it's not easy to find that kind of material, this cross vault. How to cut that edge, how to cut the stone to get this sharp edges. Really, it's hard. So what I did here, we have the formwork because I built this 1, 2, 3, 4 arches, continue that profile extruded and get the shape. Then I start cut it piece by piece and mark it on site. So I put the first piece of stone until touching this intersected profile, mark it, and I have the grinder near me at the top. We are working and cut it with edge tilted to make it join between the two pieces. It's hard for the first one, and I will not repeat this kind of details. After that, when I get like another cross vault, I use a normal stone, and when you're coming to the edge, you can even dress it later on or cut it. Or you can make it easier life on your construction when you are trying to build. So the question in simple words, you have to stay on site, build with your hand, and think and find the solution on site. If you stay at office, you will not find any of these solutions.
That's for sure. So practically you reinvent all those techniques empirically on site.
Yeah, even those wedges I told you. First one, there is an images here. We didn't use them. Where is that image? That the first one, similar to fan vault. Sorry, similar to catenary arch. This one here, if you see, because the thickness of the stone are equal, when the curve coming more curvature, I put a wooden wedges. You see this one? It's a wooden wedges. Then I have to put some cement, and it's very hard to build that one. Even if you keep, you see the triangle here, you keep each stone perpendicular on the curvature. Then I said, why I put a stone, then wooden wedges, then I remove it, put some inside like small pieces of cement or rocks. So we cut this uh, stone wedges and start use it here. It's easier. For each stone, you put one or two pieces of that stone edge wedges. And this one coming very, very easy. One guy with the, we have a lot of 5 centimeter small pieces. In general, you will throw it from this stone. So we put like a guide on the table saw and cut that wedges, and it's easy to use them. So you have to find yourself the easier solution while you are building and trying by trial and error each time.
Yes, it's a very challenging, and I'm wondering if the conservators don't have some books, historical books or other treaty like Manuale di Restauro, as they have in Italy, and they can somehow, even if there aren't craftsmen to be able to build this type of things, at least to be documented somewhere and to try to read those and reproduce what you see in pictures. And also looking at existing buildings to try to understand what you really see.
Yes, sometimes that's very helpful when there is like a historical building pumped or get demolished by in our region. So it's very sad, but at the same time, I'm looking to the demolished image to see what's the content inside, how they arrange the stone, how they cut it, to understand how they build it.
Yes, that's why conservation is so important, not only to preserve, but also to perpetuate the technical of the of construction, because in practice we conserve to learn how to build practically. And you mentioned your book. Is this book, The Geometric Construction Necessary for the Craftsman, helping you in understanding those issues, or
Yes,
only the geometry?
it's helpful, especially because the book targeting the craftsman. So let's say you are working here on site, you want to do a pattern. Uh, I am at the top of the dome. I have a question, where is the octagon? How to draw the octagon inside the square? So you don't have a laptop, especially this area, Safawi Mosque. So we are away, and there is even no electricity on the site. So that understanding of the descriptive geometry and how to draw shapes on each other, it's very useful on site.
And is your book published yet? Your
It's
interpretation?
published and in Amazon long time, but maybe few months before I checked to ask to order one of the copies. It's not available. I asked the publisher to maybe the copy is finished, and I'm looking to find another publisher to maybe even translated to English.
Yes,
Or
in English, please.
yeah. Before they have that plan to translate it on 3 languages, but I think no budget.
Yes, you see, that's the place where maybe Inbao can help.
Yeah,
Who knows?
please,
You can
please.
make an application for research project, because this is very much an INBAU project and type of approach. Are there any questions, or we will wrap it off and let Maher have dinner? Is there any other question, please? Well, if there isn't, I have to thank you, everybody, and also, first of all, Maher, for this extremely fascinating presentation. And for the listener, they stay with us almost for 2 hours. I would like also to say that with this talk, we will wrap up the 2024 talks, but we are waiting you, especially those who are in the UK, on the 4th of December to the Arts Workers Guild for the TAG Awards ceremony. So please join us there. And the talks will resume again in January, and we are promising you a very nice selection of other talks. So once again, Maher, I would like to thank you very, very much. It was extremely interesting and very inspiring, because practically you showed us that with very little means, with untrained workers, just with your determination and an old book, you can build those fantastic things. And what else can be more inspiring?
Yes, of course. And if there is like a patronage of some sponsor, you can do, like I give an example. We have here in Jordan during the Syrian war, we have a lot of refugees. They put them on the camp, and that area there is I think volcano basalt on the floor available. So just if you crash it and crash it and make it like a block, solid block, it's very, very strength uh, material, and you can build a city instead of that camps and that tents. And now they are staying years and years without a proper shelter. So you have the labors, which is my problem on financial issue. If you have the labors, the free labors, we go back to Hassan Fathy, like 100 guys can build 100 house. And the material available.
Organize a school with them. Is that possible to organize a school with them, to train them on site?
Because it's you have to ask these issues through, I think, the UN and that organizations to the related to the UN, not easier you can access and have that permission locally.
I see. But it's an idea very much worth taking in consideration. So once again, thank you all very much. Thank you, Maher. And I think we will wrap it up here. And hope to see you all, first of all, at the award ceremony, and then in January at a new series of TAG Talks. Thank you all. Thank you very much.
Thank you. Bye-bye.